happens here. Okay, testing, 1, 2, 3. That is a bit loud. Let me keep testing this. Still testing, still testing. Is this awkward? I don't. Okay, it was good. Okay. I might want to turn it down just a bit more. Okay. So let me post these links, and then I will start talking to you guys. The audio, no, why is the audio popping still? Well, we'll have to do it down further. Maybe 27? Hello, testing. Okay, that's good. I'll take that. Okay. Okay, number one, for people here, if you go to lecturecode.herokuapp.com, this is where the code is going to be. So this is a nice app that I'm listening to myself talk, and that's not helping. So this is a nice app that I made. It copies all of the code that I write and then puts it on the internet. The coloring might not be great because I don't know if I put in shader colorizing. So just point is, if I make a change and you're like, yo, I didn't catch that, don't worry about it. I prefer you not stop. The reason I did this is so people didn't have to stop me midway through actually typing to be like, yo, go back to that other file. So just go here, copy and paste it. You guys know how to type. I don't need to test you on that. So just copy and paste it. The important thing is that you learn the concepts. This shader here, that was a test. Don't worry about downloading it. You don't need this right now. We'll be getting into it. Frankly, we might not even get to this one, given the amount of content that I want to get to. But yeah, we'll do that. What was it? Oh, I was going to post the links to this. Copy link address. And put that in general, shader tutorial. Yoink. Oh, that's not what I want. No, stop it. It's this one. Nope, not that one. Where is it? This one. This one. And this one. Okay, that should be good. Fantastic. What was it? Okay, right. Okay, so Unity has been weird to me. I've been using the 29. Oh, I don't need that. The 2019 point something, the 0.3 beta, which don't use that. I'm still going to be using it. It has a lot of problems. One of which is occasionally it freezes. So if that's a problem, I'll quit and figure it out. But without further ado, let's do the shader tutorial. So I didn't have any slides for this because I made this. I had the idea to make this on Wednesday, and I've had time, but I've been tired. All right, so we're not okay. Don't blame me. Okay, so what I'm going to be talking about today is one for sure shaders. I have a lot of scenes here. Don't worry about there's a bunch of nonsense here. Don't worry too much about it. Maybe I should have done a clean scene. Actually, yeah, let's do a clean scene. So I'll just make a new thing. Open Unity Hub. So the first thing, yeah. So before we start, guys, open up Unity. This is going to be a Unity tutorial. This stuff is concepts are transferable. Granted, Unreal uses a node graph for its shaders. Let me use a non-terrible version. So that's not what we're doing. We're doing code. So code is a bit harder and a bit easier in certain regards. For all the regards you can probably think of. Shader test 2, sure, I'll take it. So just create that project. It might take a while to start. That's why I say doing it now. So what we're going to cover today is first the post-processing stack. I'm not going to go deep into it. I just want to let you guys know that it exists and that you should use it. Primarily because The shader that we're going to be making, or at least one of them, if we get to it, is going to be using Bloom. And so a lot of people are like, yo, why I'm using HDR in my color, but it's not making the glow effect like all of the tutorials online say it does. That is because you probably don't have Bloom on. Bloom is a nice thing. It was invented. You can tell it was kind of invented in the 2000s because it, like all games that came out then, like look like there's a coat of Vaseline over them, because everybody started using Bloom then, and it was like, guys, Bloom is the greatest. Let's put it everywhere. Everything's going to look like a dream sequence from like a 2000s movie. It's going to be amazing, and it's not. Let me tell you. So, Bloom still exists. It's still a good thing. It's good for like small effects. Actually, I think I can probably show you a nice bloomy thing. Yeah. So like that, the way that that glows, that wouldn't happen unless there was Bloom. You can get the like, it'll look like there's like glowing blue, but it won't look like a light because it doesn't shoot out a bit. Like it you can tell. It looks like a light. Regardless, I will show you first the post-processing stack because it's super easy, because all you have to do is once you open Unity, you go to the package manager, which is either already a tab that exists, or you go to Window Package Manager. It'll take a bit to load. You scroll down, and you click on Post-Processing, and then you hit Install. And I know that like this is kind of a boring part. I'm sorry. It's going to be like, yo, this is just me dragging things around. But this is important. Trust me, when you make games, so it's nice if you make a functional game. It's nice if you make a fun game. But no one's going to care unless it looks good, kind of. Right? Like video games has the word video in it for a reason. That's because to play the game, you need to see what's on the screen, right? You need to know, man, there's some videoing happening. And if the video doesn't look good, well, again, sorry, the game is going to feel less fun. Like, genuinely, like, you know, the visuals will even impact how you think. I mean, like, how do you know that a gun is good to use, right? It's because you see that it has a nice recoil. You hear that it has a nice sound. Every single thing, no matter how functional you think it is eventually an aesthetic feature of your game, which is the broad thing. This is actually sort of like what Sean had at the beginning of your tutorial. Yeah, I know, exactly. I'm stealing that because, again, I have literally nothing, and I'm waiting for this to install. So now that we've done it, I don't have your slides, though, so it makes it actually 10 times worse. But I do have your slides. I just don't want to bring them up. Like, I can only steal so much from you, Sean. God damn it. But yeah, so once you get post-processing, you went over like mapping and whatnot, but I'm not going to do that. I'm just going to show colors. So you'll notice it's installed by the fact that nothing has happened. That's the great part. So what you have to do, I wish it had, like, it really should give you prefabs, but what you do is you create an empty object. I call it post. And you add a post-processing or post-process layer. Not layer. No. Post-process volume, sorry. There are 3 post-process things. You have to put 2 of them in your scene. One of them is a volume. One is a layer. So this thing, it's called a volume because modern post-processing is not global. So there's actually a flag here that says global. That means that this will be for the entire scene. But let's just say that you have like maybe an underground area that's like evil green gooey lab or whatever, and you have like a nice pretty outside, right? And so one might have a different post-processing effect than the other one, right? Like one might have a green color grading, one might have a very bright color grading. You can do different for different areas. We're just going to do global. Weight is how much, post-processing can overlap. So like weight is how much do I care about this post-processing thing? So like if you're overlapping one with another, that's how that is. Priority is kind of like stacking order. So like how important is this post-processing effect in the overall scheme of things? But don't worry about it too much because we only have the one. You only ever really need the one. Just hit new. That will create a profile. If you're wondering where does that happen, like I hit new and I don't know where it is. It's in scenes. It will create a folder for you. In that scene, sample scene profiles, it is the name of the scene profiles. It will create a post-processing profile in there. if you want to like not have this ugly, like if you have like 10 scenes and you want to make post-processing things and you don't have like want to have a bunch of folders that's a bunch of garbage, you can just right-click, great, post-processing profile. It's the same thing. Oop, not that one. Same thing, but I just do the new one because that's faster and I don't really care. So now that you have this, the nice thing is you can edit it both by clicking on the object in the project window or just by clicking on this thing. It's kind of like a material in Unity. Both you could, if you select the material, you can edit it there or within the inspector. So what you can do is you can add an effect. Let's start by adding color grading. We're also going to have to change one thing. And the cool thing is you'll notice it happens immediately because nothing happens. And the reason for this is actually one, change tone mapping to custom. Because right now, by default, every effect in the post-processing stack is like default. So it won't actually change anything no matter what. Change it to this, and you're like, wow, it's so different. But the reason nothing has changed is because there's another part of this. So I have you change that just because when we add this, I want to like make sure that like you see something happens. So now that you've done that, click Add Component. This is where the layer comes into place. Layer is for your camera. So your camera can have, I don't know if it can have multiple layers of post-processing. I assume it can because it has, it's layer. Because layers implies multiple. Never actually done multiple. Regardless, you'll add it and you're like, wow, nothing also happens. It's because, again, we should change the layer from nothing to everything. Basically, this is like a culling mask. And now you'll see, wow, it changed. The colors are darker. I know this is a lot. I think it's really dumb that this is how this works. If you open Unreal, you just like it by default has this work, and you could like you have to like work like extra hard to turn it off. Frankly, with Unity, there's like 10,000 different things you have to remember to do. And by 10,000, I mean like those 3, but it's an annoying number. Okay. Regardless, you've gotten that to work. The last thing I want you guys to do is go to project settings. So either by clicking on this tab, or you go to File or Edit project settings. That will open up this. I would dock it. The newer versions of Unity let you dock the project settings. It didn't let you do that before because Unity doesn't have UI UX people, I guess, or only recently got them. So click on Player. So if you're wondering, what are all these settings? The Player Settings tab is for all of the settings that they didn't feel like putting in anything else, because there's literally everything in here. Like the default icon in the Player tab, the default cursor in the Player tab, the resolution presentation in the Player tab, because why care about organization? Regardless, the thing you should care about, let me actually undock this so you can see this better, is the setting, code quit, cool, thanks, is color space. So color space is a big thing, like abbreviated version, different kinds of, there are different ways of representing color, and those different ways of representing color within code, like virtually, allows different ranges of color. I can actually probably Google this for like a nice representation. Color space. It's actually really cool. Yeah, color space. It's neat. Look at it. There are different ways of representing color. This is like visual light spectrum, and certain kinds of color. You might have seen this if you like edit a file, or like especially if you use Illustrator. Like CMYK is has a different range of color because printers can only print in certain, ink can only combine to create certain things chemically. Computers can only show so much. I think like the most people have, it's either like the one that Macs use, or it's like the Adobe. I guess there's Pro Photo RGB. That's for like I assume camera people. But I think most people like the most. It's either Adobe RGB or sRGB. I think is the most common. Possibly. Regardless, yeah, displays are sRGB, but like files save in Adobe RGB, right? Like you could, like when you import things into Unity, like there's a way to import it as sRGB or like ARGB. Regardless, really technical stuff that you don't need to worry about right now. But color spaces are different. I think gamma and linear space is also different. Let's just say that the way that color renders can be different. Linear is special in that you can actually go beyond 0 to 1. So light color in computers exists from 0 to 255, 0 being black, 255 being white. And then you can like vary different, like you can vary the RG and the R-ness, the B-ness, and the G-ness to get different colors. I'm sorry, this is a lot. Again, if I had slides, maybe that would go better. But like, I mean, like I can show you like in a material, right? Create material. Right, I can vary the R-ness and the B-ness and the G-ness of this to get different colors, right? Where again, F is the most white of them. Regardless, linear lets you go beyond 0 to like go beyond this range technically. What does that mean? It means you're like, if you're like, whoa, what does it mean to go beyond the brightness of white? That means your white is just really bright. That's what it is. Again, that's what bloom is, right? So like if we remember this thing here, you have this blue, but it's like brighter than blue should be normally. So rather than it just be like whiter blue that doesn't, kind of have a lightness to it, bloom gives it light. Regardless, that's the important thing. Where's the project window? There it is. Changes from gamma to linear. It will change. It will like do this little loady thing where it's like changing stuff. The more stuff that you have in a project, let's just say, change that first before starting a project, because what happens is if you have content, it has to like go in through it and say, hey, do I need to change this from gamma to linear? I don't know why it needs to do that, but it does. Sean, do you know why it does that? Like why it needs to like load through things? Yeah, that's what I thought. Yeah, so it has to re-import your textures to like make it in linear space, because in gamma space, it doesn't let you do things. I think you can probably like Google this again, gamma space, and linear space. Yeah, so like here's a good example of it, right? In gamma space, it'll just get more exposed and look bad. It'll look like just a bad picture. Linear space it will brighten up and it'll like kind of add this, brightening effect. I don't know like how to describe it best, but like you can kind of tell it just looks like a bad picture or a good picture. But yeah, so, oh yeah, it has to do math because of it. Yeah, what's up?
So why would you choose gamma?
I think it's cheaper to do, right? Is that why? It's like cheaper computationally? Also maybe because like that's just the way that they did it in the past, and also that's like the default. Like I thought.
It's because the forward lighting is a big part of gamma. It didn't really matter.
Yeah.
The color that was like in your texture was basically the color that was going to end up on screen.
Oh, because we have lighting and now like light interacts with it, like with everything.
The reason why you generally use linear space over gamma space now is because when you have a bunch of lights in a scene, in order for the lights to like add up correctly, you need to do it in linear space so that colors don't get like unreasonably exposed when they go beyond. Because like if you do it in gamma space where it's curved, yeah, you can see how light gets bright more quickly than it should, and the difference in between darks and lights gets like unreasonably, like you can see how shiny the highlights look on the bottom left is.
For the people on the stream who can't hear Sean currently, it's basically because it looks bad in gamma. That's the answer. Yeah, no. So like there are math reasons. Generally speaking, I don't like to worry about those until I need to worry about it. For now, basically, linear space it makes like it looks better because I mean like there were tricks that they did back in the day. Whatever, it doesn't matter. Linear space is better. What? Oh yeah, there you go. Yeah, so like you're like, what is, yeah. So regardless, yeah, what are they doing? You can, look, the answer is you can Google it, all right? The reason, look, so the way that I like to think of, again, the way that I like to think about this, and this will be a theme of the talk, is that the reality is a lot of the work that you're going to be doing is super hard, and you can bother yourself with the details, and that's good. I was not a media person. I didn't take like graphics, so like I don't know the underlying stuff of a lot of things. What I do is I Google stuff and I get stuff to work. I'm a hacker, all right? What I care about is getting the end product done. It's significantly faster, and frankly, I feel like I learn better this way. If I get stuck in the minutia, I'm going to be thinking about the minutia, not thinking about like getting practical stuff done. So like by all means, definitely learn the underlying features. Like, who's the guy that made The Witness? It's not Phil Fish. It's the other like pretentious guy, Jonathan Blow. He has talks about like how society is going to end because we're forgetting about the underlying causes of things. But I don't agree yet, especially at this level. So guys, worry about what you need to worry about. You guys are artists. Your goal as artists is to make art, not necessarily to learn learn how every part of the sausage is made. If you need to know that to make your art, do it. But until then, get stuff done, because if you get stuff done, you will be motivated to keep getting stuff done, not, oh man, what is linear space? Oh my god, I'm so confused, and then you stop. I like to worry about things as they come to them, and I think that's a better way to go about life. Regardless, we set it to linear, and then that fixed everything. Talk about getting stuck on minutia. See, again, like,
15 minutes on an
literally, and it's like, it's practically Boolean. So yeah, this is to say you can get caught up, and this is actually a big thing with shaders. The shaders, more than anything, like any part of game development, like it seems to me, you can get stuck on, what does this mean? How deep can I go? Because shader code, it looks super complex. You're like, man, I can do some crazy linear algebra stuff to get this to look the way I want. Or you can just be like, yeah, let's kind of cheat it, I don't care. And then you'll get the job done. Or you can be like, man, I could figure out exactly how the shader was made, or I can just kind of copy the code off a tutorial and then then finish the thing and sleep. I can tell you right now, sleep is better than math, I think, in my opinion. So value that. In any case, it's now linear. Everything is good in the world. Let me actually show you what this means. So now in our post thing, so we've added color grading. Before it would give you an error saying, yo, you're not in linear space, you're in gamma space, so like the colors aren't going to be quite right. And you also couldn't modify the grading curves. We're not going to modify the grading curves, but I'll show you, like, you can modify like a bunch of stuff. You can make it, I don't know, like really green or stuff. You can modify the color things. The biggest ones I use are generally here, or like these. Like temperature is nice, so like, for flying whales, right? If you want to like make it, for yours, right? You have it a very warm color. In this case, you can make it cool, so things kind of look bluer, right? So like maybe your whale will now go color-wise better with everything else. You can modify other things, color shift, exposure makes things like super bright. Now it's white. That's not fun. Regardless, you can modify a lot of stuff. That's nice. Another nice one I like to add is a bit of vignette. Vignette, like, you'd think that, like, man, a vignette, it's like, it's just a black gradient. Who cares? But, like, straight up, that vignette does, like, a lot of work. So, again, by default, it doesn't do anything. 0.2, maybe? Right? I don't know if you could tell. Let me, like, make it darker here so y'all can see. Like, I tend to find that like the vignette actually does a lot of work in making the game just like more dramatic, right? Like, I mean, so here, boring, bland, flat, dramatic, right? Again, not everything needs a vignette, but like, man, it's just like a solid way of giving things just a bit more, I don't know. I say dramatic, that's what I tend to think, right? Because it just adds a bit of black to it. That's always nice. Then we have aim and occlusion is nice. That one, we don't have a lot of models, so we can't really show that off. Sean's a big fan of chromatic aberration. Actually, in Demonstratum, I like cranked this to the max. You can't see it. Let me actually add a model here. Let me add a 3D object, a cube. I don't know how well I can get this effect to work, but let me go to my post. Chromatic aberration, intensity, let's make it like out the wazoo, right? So you can see stuff at the edges. It kind of, so what it does is it like separates, it separates the RGB channels and just kind of like offsets them a bit at the edges. I don't know what this is trying to replicate. I assume it's just what cameras do. Is that right? Yeah, it's lens distortion, and I assume, right, because lens distortions, so in real life, lens distortion. So like in games, you could just distort the lens just by moving the pixels. In real life, I assume the distortion actually changes how light passes like speed-wise, so like the color changes a bit. I assume it's kind of like the Doppler effect for light, maybe, or no, I guess refractive effects for light. Yeah, that's why like refractions look weird. I don't know. Regardless, that's why when you shoot the light through the prism and you get the dark side of the moon effect. There you go. Yep, physics. Regardless, that's what this does. Having a lot of it, gamers will complain. Like, I swear to God, whenever I see like a new trailer, and like the first comment I see is like, "Yo, that chromatic aberration! Like, what's going on?" But if you add it like subtly, it looks kind of nice. Doesn't matter. Regardless, the one that I want to worry about right now is bloom. Bloom, again, the thing invented in the 2000s to make everything look like Vaseline, is nice. If you make it like 0.5, you'll notice right now it's become a bit brighter. What we can do, this is an HDR, is it? Of course not. Oh, emission would do that. Yeah, that's true. So we had some emission. Right now it's black. Let's make it like blue. Add a blue emission. So you'll notice nothing's happening. But let's, hold on, did I not? Oh, I haven't applied it. Classic. So let me bring this down to 0. So right now it's just kind of like adding blue to it, so you can't really tell. It's a bit brighter. But as I increase the intensity, Energon. Y'all get that reference. It's Energon cubes, right? Transformers? God, you losers. Okay, yeah, so like, yeah, look, guys, Transformers was a great cartoon that was exclusively to sell products. Regardless, yeah, so it makes it really bright. If you make it, it'll make it so garish that it's a circle now. What's up?
Did you put that on the block or on the post?
Oh no, on the block. So what the post does is allow you to have this effect. So let me actually go back to post, and I turn off bloom. Wow, it's just a bright cube, boring, glowing, garish sphere, right? So yeah, that's what bloom does. It allows this to happen. So you'll note this actually isn't a light. So if I have, let's just say if I have a plane, 3D object, plane, and I'll reset, it's not actually lighting the plane blue. That is because bloom doesn't do that. Bloom is not about lighting things. It can in real-time GI, but we're not going to worry about that. Also, it does it really badly, so don't. But yeah, so the reason I would say make bloom subtle is not only because to make up for the sins of the early 2000s, is because it doesn't actually light anything. So unless you have a light associated with it, it's going to look weird. So just add a little subtle effect. It'll look nice, right? I mean, this looks like a nice glow cube. Looks cool. If you want to, obviously, you can add a light. Just go cube, light. And actually, that is a normal combination. Oftentimes, if there is a glow in an environment object, you can actually add a point light that is like bluish, right? And now it's actually lit blue. You can't really tell. I guess the directional light is too powerful. Regardless, just trust me, it works. Yeah. Okay. So I just wanted to show you guys that. What's up?
Sorry, I missed it. How do you apply it to a single texture, the bloom?
Well, so the bloom is the post-process effect. The texture, let me click on this again. The texture itself is the thing that has it, that has the HDR color, giving it the bloom. So here in the color, in the material, you can add an emission, and then you can edit that emission color. There's also a way I'll be showing you in the shaders that you can add bloom. You can make the base color have HDR in it. But yeah, there is this. But yeah, so I just wanted to show you guys this because now your games can look better. If your games look bad now, I will come to your house and I will yell at you. Yeah, you have no excuse anymore. But yeah, trust me, this is just a really quick and dirty way of making, even the simple stuff. I made a, I think I showed this before one time, but I made this for game design class. Again, subtle vignette, color grading. It's just a really easy way of making stuff look a bit better, right? Before this looked kind of bland and washed out. That's often what video, like if you know what, like, if you see like a Unity asset flip on Steam or like Baby's first Unity game, it looks washed out. Colors are like weird. Color grading, it'll make everything look better. A vignette will make it just look just a little slightly better. Okay, but yeah, so do it. Okay, so shaders now. So thus far it's only been post-processing stack. That was just to like make you guys know how to make your game look a bit better. Now is to actually what are visual effects, what are shaders and whatnot. And let me show you hopefully what we can finish by the end of this. If not, I will at least post this. Where's Reveal and Finder? Because I made the other thing, and I made this in the other thing. Oh crap! I put this on the. Okay, that's fine. All right. Well, documents, Unity. Where is it? Shader tests, assets, materials. Jesus Christ. Ring. There it is. Fantastic. Let me just drag this in here so I can show you guys. Hopefully, what the last thing we can make is. Let me open this back up in Finder. So we have this one. Where's the other one? Scene, sample scene. Where did it go? No. So there's this one. Fine, I'll just open it up again. Fine. Shader tests. Assets. Materials. Nope, materials. Ring. I'll drag this into assets. And then I will drag models. Oh, this might break. Might break my code copier, so don't worry about it. Let me see if that happens. Nope, we're fine. Okay, so it actually can parse blend. Actually, I want to see what that looks like. So again, lecture code. Did it not upload? Why would it? What? Oh, all right. Well, it like half works sometimes. It broke one time, and I fixed it really quickly. So if it doesn't work, it doesn't work. In any case, if you're here now, and you can see what I'm doing. It's importing assets. What I hopefully will get done, so let me get rid of this. Let's get rid of this. So open up assets, ring, make this 0, 0, 0, and then open up the ring texture, and then apply this, and then let's move this out of the way. So we might not get this done, but I want to show you the components of this because VFX. So the VFX is actually the perfect thing for the video game generalist, because if you don't have to be the best at every single aspect of video games, but you need to know a little bit about everything. You need to know a bit about modeling and a bit about UVing. Like it's nice to know a bit of like animation in model animation, not necessarily, but sometimes. You need to know a bit about code, both shader code and C# code, and you need to know a bit about the post-processing stack. Regardless, what I wanted to replicate was this effect, the bomb ring effect. And so I have this thing that is vaguely like that, and you'll see I can kind of do this with it, right? So it disappears, the lines get thinner both along the X and Y of the line. And it's not animated, so I can make a script to animate it. If we get that far, we get that far, because actually I want to show you how to do that. But VFX involves all of this. So it's on a model that I made. I needed to custom make this model because there needs to be because I need to make the UVs in a specific way. And I'll explain what UVs are for those who don't know. And I needed to make this texture in Photoshop. I needed to know what that texture would do. I needed to, in theory, you don't have to make the texture in Photoshop. You can just download it and then modify it however you want. I needed to do a bunch of linear algebra. That's not the right. Why did it open up this one? Oh, okay, hold on. Sorry, recent Unity things doesn't work on Mac specifically with Visual Code. So I have to update. Hold on, how do I? I can't even press the buttons. There. Okay, so I have to update it, and then it'll work. I think. It does this thing where it doesn't open, it opens code, but not the file you requested. In any case, once that installs, we can get going. Boy, let me stall here. How was your day? What's up? Yo. You tried to help me out here. I'm sorry. It's fine. It's fine. It's installed. Okay. Yeah. So this is what a shader file looks like. Don't worry about opening this quite yet. But actually surprisingly simple. Most of it, most of it's commented out. You don't even need this. That was from previous things. Straight up, most of the work is being done by this, and I will show you how to make stuff like that. Shader code, like everything else you do in anything ever, is a notion of composition. Oftentimes, you'll probably look at a shader tutorial online and think, yo, how do they come up with all these 20,000 different things to do? It's because they thought of that one thing to do, and then that other thing to do, and then that other thing, and then that other thing. And they put those two things together. Never think about it as, holy crap, they did this one line. I would never have thought of that one line. It's because I thought of 3 different things separately that didn't work, and then I got one to work, and then I got another to work, and eventually it came together. In any case, this is what it looks like oftentimes. This is what shader code looks like. It's a bunch of stuff. That is to say, every single aspect of game development comes together in shaders. So let us not start here, because this is hard. We're going to start with something very simple. We're just going to start with, let me make a folder. Always do this. So organizing shaders is hard. I've never known, actually not material, sorry. Organizing shaders, I've never known how to do it effectively. I think the best way for me to do it now is to create a materials folder. And then in the materials folder, create the folder for the material. Let's just do test. And then so within the material folder, I will contain the texture for the material itself, and the shader for it. I know in other games it might organize it as they'll have a shaders folder and then a textures folder. The issue with having that for me is just that it's so separated. If I want to find everything, I like it in one place. I know that's weird and pedantic to talk about how my organization works, but trust me, that's half of games, if not more. So right now, let's just go to material. We'll call it test. And what I want to show you guys is all of these shaders here. See you guys. I wish you could stay so you could help me even more. Wait, hold on. Okay, cool. I'll be talking to you later. Well, no, not this one, but in the future. Okay, cool. You can do other tutorials. Fantastic. In any case, yeah, so what I want to show you guys is this thing. So if you see this drop-down, these are all of the shaders Unity comes with by default. It also comes with our custom ring shader. I mean, I do because I have it. You don't. But you'll see, wow, there's a lot of stuff. Let me actually get a cube. Let me get my cube back and then put this material on it. A boring white material, and let's just see what we can do. So there's a bunch of stuff here. What I want to show is unlit. Wow, unlit is unlit. That, what it says on the tin. You can change the color, but you can see there's no shadows on it. I don't think, even if I had another cube, I don't know if the shadow would be cast on it. Yeah, so shadows are neither cast nor, so I think shadows can be cast from it, but not on it, is the thing. So I think actually, so if you have this plane, actually no, I guess not. So shadows cannot be cast from nor on it. So it is truly unlit. You'll notice, a lot of indie games kind of do this. Unlit is actually, so I recommend actually if you don't want to work with shadows and getting things to look great there, unlit's not a bad thing to do, just because it's straight up the color. You'll notice because there's no, because I changed it to unlit, the color is stronger, right? Because what the standard shader has on it is the smoothness and metallicness on it, which can change how the color interacts with the environment. And oftentimes that can make the color dull and less interesting. Whereas if I change it to unlit, it's just the color. So like it is what the color is. It can be as bright or vibrant as you want it to be. I say this because even without you touching making your own shaders from scratch, just like screw around with the shaders here. There's a lot you can do with it. Like a lot of these are probably useless to you and are very specific, like nature. I think that there is a speed tree integration. Like I don't know what this is all about, but this is what a speed tree has on it, I guess. It's basically the standard shader actually. Regardless, particles, different stuff does different stuff. Skybox probably has fun things. CubeMap. That's kind of fun. Doesn't matter. Mainly unlit is there, but let's go back to standard because the standard shader is kind of what you get when you first create a shader, and that's what we're going to do right now. So the standard shader, or actually in a few seconds, standard shader has a few things that you can do with it. It has metallic and smoothness. Sean went over this in his tutorial. I don't want to go dwell on it like we did with gamma and linear, but this is to say this will look more metal. This will look smoother. I think it's best shown with a sphere. Let me reset. Yeah, so so that looks very smooth and metal, whereas you can also edit the material in here. If I turn this down, right now it's just smooth, right? And now it is just metal. Just metal is weird. Frankly, I can't even things aren't just metal in real life. They're both smooth and metal. Kind of, I don't know. Regardless, I would never, this material is weird to me. It's strange, right, to look at. Also, let me turn off the grid because it's in the way. I don't know why that's up front. Just turn that, no, not what I want. Show grid, there we go. Actually looks kind of like a rubber ball, but I don't know why rubber would be metal. Yeah, right? It doesn't look like 100% metal. You're like, why? Who said this was metal? It's bad. So don't worry about it. But these are things you can change. Obviously, all of these maps are textures. I can put a texture on it. So that texture is being multiplied by this color. You're thinking, wait, you're multiplying a texture by a color? What does that mean? I will show you. That is math. I know. Multiplication is in fact math. I wasn't sure if you were aware. Regardless, you can multiply colors and textures. I will show you how that's done. But yeah, so by default that's white. If you multiply white by the texture, it's just the texture. Why is that? Because white is 1.
Identity matrix.
Exactly.
Yeah.
It's not a matrix though. It's just the number 1. The texture is a matrix, but you're multiplying every aspect of that matrix by 1. So it's not like applying the identity. So it's not matrix multiplication. You can do that, but that's more if you want to do 3D stuff. But we're not doing that. No, this is straight up. You're multiplying everything by 1. Well, no, wait. The 1 by 1. I thought identity matrix is 1s across the corner.
Yeah, but if it's one by one, it's just one.
Yes. Okay, yes. Guys, math jokes, the height of comedy. Regardless, you can also add maps to the metallicness of it. It's kind of neat. So the areas where it is white, it is 100% metallic. The parts of it where it is black, it is 0% metallic. And the parts in between are some degree metallic. So that gives you kind of in this case, a neat effect, right, where we got this foggy mirror kind of thing, right? I can assure you this is not invisible. This is just it reflecting the skybox. But if you know in modern day, let's open up polycount. I will be showing you these web going forward. Let's see if I can't find a good thing to show it to you with. Actually, no, maybe this would be good. In modern day rendering, it's not metallic smoothness. It is roughness metallic. This is sort of good, right? You can kind of see in here, right? It's paint and then metal. The metal is shiny. The paint is not. So in that material, that's using a map, right? Because that's one continuous material. In the map, there's a thing saying, okay, this part should be metallic, this part should be non-metallic, this part should be smooth, this part shouldn't be, and you can get some neat effects going on with that. That makes it look realistic. There's a lot of stuff going on here that's making that look realistic, but that's just one of them. In any case, just note that, what that means. Because you make it a map, that means you can apply different parts of this model, can be different things.
Can you put anything, like any picture there, or does it have to be?
Any picture.
Okay.
You can even do this. This one. Obviously, some things are made to be textures, some things are not. These are sprites, so it looks dumb, but yeah, so anything. Anything can go on there. Basically, I will tell you what UVs mean, if you don't already, but as long as your models contain the UV. The model contains the thing that says, hey, this is how you apply your texture. Cool, let me actually get rid of that because it looks bad and I don't like it. Okay, the normal map, I don't have a normal map here, but normal maps are interesting. I wish I had one. Yeah, in Sean's tutorial, he actually went over this. Doesn't matter. The normal map is things that add extra 3D detail. So the nice thing about color is that it has 3 components, right? R, G, and B. The fun thing is, let me Google normal map. Normal map. That is a normal map. That's what I came up with. In any case, yeah. So in any case, here's a normal map, though, right? You've probably seen these in games. If you ever modded them or just messed around with stuff, you've probably seen this around. You're like, why is this blue and this red and green? That is because color is held by R, G, and B. Guess what is also in 3 dimensions? Space. I know. So the neat thing is, what it does is it goes, okay, in reality, right? So this is a flat desk here that I'm touching here. The normal of this desk is straight up, right? Now imagine this desk was ruffly, right? We actually the wood in it was really deep and grooved. Well, the normal would be kind of different, right? Depending on the angle. Well, so rather than modeling that in 3D by actually making those, you can fake it. Now in reality, what you would do is you'd actually model it first, bake it, and then you'd you'd put the detail map onto a lower detail thing. There's that whole process, but don't worry about it. Imagine you just have a normal map. What you do is, using the normal map, you can just say, okay, I have a flat surface. Well, I'm going to fake the normal map. Right here, it's going to be a bit different. Here, it's going to be a bit different, right? So this rock texture might be on a flat plane. Because it's on the flat, because of the normal map, the light will bounce off it at the wrong angle, right? Rather than bouncing off it at the flat angle, it will bounce off it in a different direction based on this normal map. So by default, the default normal is a kind of grayish blue. That is because it is 0.51 being x, y are 0, z is 1, right? So z coming out is 1. And then you can just kind of modify it, so your normal is going to go this way or that way, right? So parts that are a bit red are going up, a bit more in, I guess, the x direction. That are things that are less red are going, the opposite direction in the x. Greens are going, different directions in y's, right? Does that make sense? What's up?
So generally does light usually bounce off straight?
Light bounces off based on the normal, right? So the equation for vector bounce or vector, what is it called? Something, right? So the way you bounce out, there's literally a function for it in vector reflection. Right, so hold on, vector reflection unity. I think there's literally a function for it, and it will explain vector 3.reflect. Yeah, so you need the normal, so here's a good picture, right? So the normal, the reflection of light should be based on where it's the vector of its incoming approach, which is which the particle knows, and then the vector of the plane that it's bouncing off, which the plane knows. But if we modify this, it will look like it's kind of dimpled or whatever we want it to look like.
So we're just overriding Unity's
Yeah, in any engines, of course, right? Yeah, so we're just overriding. So it's basically Okay, yeah, so by default I bounce off this way, but hey, I can bounce off whatever way you want me to. So you can just kind of tell it to bounce off different ways, and that's what's happening with that. Height map, let's not deal with that. Height map is actually legit. There are ways of, if you guys know what parallax is, you can actually make stuff that is in behind move at different speeds. So like the height map, what it does is it actually makes pixels that are like the white. Actually, I think I don't know if I apply it here if it will look good or actually even work. Let's see. I don't think it will. Yeah, it probably won't work. That's fine. Oh wait, hold on. I think it was, if I ramp it up. Let's also give it the albedo of that. Yeah, you can actually tell here. Okay. Huh?
Whoa.
So again, it looks 3D. It is not. So what it's doing is a thing called parallax. It is faking. So normal is based on the light light dispersion, right? So it'll bounce the light off. This is okay. If a pixel is, so if the thing on this map is black, I'm going to push that pixel back on the screen based on the direction of the normal. So I'm going to push that back, and it will give this fake 3D effect. It is really neat. Actually, you can use this effect if people have played. Actually, I don't know if this is how they did it here. I think they did, or maybe it was a cube map thing. Like in Spider-Man, you can look in the windows and stuff is there. And it's like, whoa, how there's actually nothing behind that. That's just a texture. They did some kind of projection stuff, and based on where your camera is looking at it, it will kind of bend. That's the reason you can have sometimes there's actually glitches where at the corners of buildings, one window would be looking into one completely different room than another, and you're like, how is that happening? That is because there's actually no room. It is just a 2D texture that looks like it's a room. Using parallax or something like it. Again, I haven't looked into it, but actually I think there's a tutorial on it. I think I will Google this right now. It is Spider-Man window shader. Yeah, so this guy did it using shaders. Yeah, so if you want to actually know how it works, you can make the shader yourself. I think straight up he leaves the code, but yeah, so you can make. This is kind of I think it's actually like a skybox works, but regardless, you kind of have this cube of. Oh, I guess he doesn't show it well enough. Okay, there's basically a cube of textures, one for the back, top, bottom, and front, and then you can do math for it to fake it being there. It's really neat. Regardless, the power of shaders. We're not going to be doing this at all. But this is to say there are resources out there for getting stuff like this done. What is the next one? Occlusion. Occlusion is that's a more advanced thing. So imagine you have a 3D model. And you know ambient occlusion. So light tends to get trapped in nooks and crannies of things. So with 3D models, rather than actually using screen space ambient occlusion, which is a very to do in real time is a very taxing effect, you can just kind of create a map which kind of darkens areas of your model which should kind of have shadow in them. We're not going to do it here, but that just suffice to say that works. And I guess another one I want to do is emission. We already showed that. That's bloom. Emission straight up just adds a color on top of your object. I'm adding red to this. I can make the red really powerful, yada yada. Cool thing is you can also do this with a map. Hold on, let me make this not as crazy, right? So different parts of my model are now lit up, and parts aren't. Yeah, it looks like lava. In fact, guess what we're making today? So it's not moving right now, but lava moves. Why isn't it moving? So displacement. It's not gonna quite be what that video did. I can show you how to displace UVs, but that would be kind of annoying. Actually, in theory I could. It's like a really simple thing. But first, let's just move the texture. So what we're going to do is right-click, create, and please follow along if you want to. Be learning. You learn better when you do. Let's make sure that this is working. Create, shader, standard surface shader, and call it lava, because that's what we're doing right now. Again, as I said, I'm making this up on the spot. We were not going to make lava before you said lava, and I was like, perfect, let's do it. So we're going to start with lava, and then hopefully I can get to the ring shader. Again, we spent like 40 minutes to an hour talking about linear space and doing this, but I think that was worth it. Again, I want to give you a primer for things. There is a lot deeper stuff you can get into with all of this, but you learn that as you need to. So let's make sure that my stream is still going. I just want to make sure. Awesome, it is. Let's see. So we created this shader. I just want to make sure that this is still working. It is not. Let me open this up. So double click it to open it up. Don't save. Maybe like just, or see if this opens up in lecture code. I guess not, if it's going to be like that. Really? Lame. Okay, well, I'm surprised that it doesn't work. Okay. Yeah, so I guess you can't follow along that way, so I'm going to have to slow down for certain things. But this is what it looks like. Let me make it bigger for you. So you'll notice when you create a shader, there's like a bunch of stuff. And you're like, what does all of this do? And that's what I thought, and then I never touched shaders for like another semester. Don't be like that. Don't be scared. There's a lot of boilerplate. It's actually, Unity is far nicer. In theory, it didn't have to give you any of this by default. The surface shader is actually a very convenient shader. It gives you a lot to work with. So in fact, now that we look at this code, let's go back here. What you can do is either A, drag this shader over the material, or click on the material under shader, click custom, and then lava. Actually, let me tell you right now. So you can do this. We'll mess with this in a second. If you look at your code at the top, shader, it says custom/lava. You can change this. So if I want this to be under liquids, lava, I can save that. In Unity, my shader is now liquids lava. So now instead of being in custom, like my ring, it is now in liquids lava. Cool? Stay organized. Okay? I swear to God, I have several projects where it's all, everything is in custom. And you're like, all right, well, shit, now I have to go through like 10 different things. You can do that. But it's better to be organized. So by default, you'll notice, wow, it's similar to the other one, but it has less stuff going on, right? It's got our metallic, right? You can still modify it. It does everything metallic does. It has smoothness, does everything smoothness does. It has albedo. It doesn't have like the weird circle thing, but it's still, albedo is the texture. I don't know why it's called that. I think there's, let me define albedo. I'm pretty sure albedo is, yeah, it has to do with light. Okay. I don't know why they use albedo. That's just the word they used because they wanted to sound smart. Doesn't matter. Okay, yeah. So you can use the texture, and of course you can change the color. Right? Cool. Awesome. Let's start modifying stuff. So up at the top here, you'll notice all of these properties correlate to the properties you can modify, right? Color, main text, glossiness, and metallic. You'll notice that the names don't quite match up with the variables. So the neat thing is, properties isn't real. It doesn't exist. I'm blowing your mind, but it doesn't. This is actually, none of this is used for the shader itself. This is for the serialization for Unity. So properties, right? So here, this is saying, hey, I have a variable color down in here, right? Color's down in the actual code. And so it should be called color in the inspector window. It should use a color picker in the inspector window, and it should start with this value. Is that a hand raise, or are you just stretching? Cool. If I change this, in fact, change it to float, this doesn't make any sense. It should be wrong. It might even compile error me because nope, awesome. Yep. It is now a float 4. It is now a 4 vector, right? So now it's not a color picker, it's that, right? So this is exclusively for the sake of you editing. So you're saying, okay, I have a variable called color. It should be called this in the inspector window. It should be a color picker in the inspector window. And it should have this one, and it should start with white, right? White is 1 on the R, 1 on the B, 1 on the G, and then 1 on the alpha. What I can do is also, if anyone knows serialized field in Unity, there's like a lot of like kind of markup-y things you can do. I don't know what they're called. Do you know what like those things are called? Attributes? They might be. So an attribute, you can add attributes to these, one being HDR. So remember how our emission was an HDR color? That means you can add bloom to it? Great, now our default color, I don't even need emission, it's just an HDR color now. Now I can glow. Wah! Yeah, so the thing is, oftentimes a problem I will have is that like, you know, particles in Unity, by default, they actually don't let you do HDR. So I need to make a custom particle shader. So I can just be like, yo, your color, just make it HDR, that's all I want. But yeah, so you can just add that thing there, and then straight up you just get bloom out of the box because, again, HDR means high dynamic range. I think just means we can go beyond the normal color range. I think, yes. So in this case, you can now be glowy, and now we've started on our way to make lava, because now it's all lava, no rock. The next thing we want to do, I mean, straight up, we can do what we did before. Cool. Hey, wow. It looks like that already. Again, because by default, out of the box, it just gives you your albedo. Just works. But I want to tell you why that works. So albedo, so you'll see here, main text, that is your main texture. It doesn't have to be called this. It just usually is a 2D. 2D means 2D texture. I don't think there's actually a 3D texture. Nope, there is a 3D texture. I was wrong. I don't know what that means. No, because here, D isn't, like, right? So, like, if it doesn't exist, it doesn't exist. So 3D, I think it does. Yeah, it's possible. I have no idea. Again, just it's 2D. Don't work in the third dimension. There's no 4D texture. Other things, right? Glossiness is a float, right? But a float that is capped between 0 and 1, so I just make that range, right? I could have made this capital F float. And if I click on the material, right, so now smoothness doesn't have that convenient slider, but unlike before where the slider is capped, I can't make this like 100, right? Here I can make this 100. This is 100 smooth. It is perfectly smooth. I don't know, it's like the most smooth. Yeah, like it's too smooth. Yeah, like it's, yeah. Regardless, let's make it range. What's up?
Where do you get your texture maps from, like the black and white?
So that I made it in Photoshop. So I would actually recommend GIMP. GIMP is free. You can add Perlin noise in GIMP or cloud noise in GIMP, or I prefer plasma noise. Plasma noise looks really cool. There are also other ways of doing it. I will show you this later on, but we've got a Gumroad. You can get a bunch of things. Gumroad is just a vendor site for artists usually. Where is my library? So I have a bunch of purchased and free things here. A lot of this stuff is free, but one of the biggest ones is Luo's free noise textures for all your noise texture needs. I have this. I use this a ton. They're really convenient. There's just a lot of nice noise textures. I will show you what they look like. But also, get into Gumroad. I have bought a bunch of tutorials and got a bunch of free tutorials on here. There's just a lot of good stuff on here. Yes, awesome, great. You know about that. I'll bring it up again later. But avail yourself of all kind of resources. Luo's noise. In fact, let me just open up that file. Where is it? Yes, Luo's noise v2. Bring that in our assets. And then I'll mess around with it. Again, you don't need this because, like, as long as you have the. Actually, let me upload this to Discord right now, just so everyone can have it. Where is ring So let me upload both Perlin and noise. Don't worry about, oh my god, you gotta be joking me. Oh, the PSD is probably too big. Let me just upload Perlin then. There you go. Okay, so everyone should have the Perlin noise. You can use this for your lava. It won't look as good, I don't think, probably. Right, so like if we select this, yeah, it's not that bad. This one's just gonna be more intense because I made it more intense. But this one does function regardless. So we're using this one, but in lieu of noise, let me show you this. It's got like a bunch of weird stuff on it, right? So the nice thing about noise, so let me tell you this right now. Going forth, you will probably look up a bunch of shader tutorials. They're helpful in the fact that they might help you with the code. They're unhelpful in that oftentimes what they'll do is like, okay, just do this really simple code thing and then just have this conveniently perfect texture. You like I complained about this in social. Like, yeah, just get this caustics texture. It's like, where did you get the caustics texture? They're like, I don't know. So they like never tell you where they actually got these textures. These are hard to make. I didn't make these. I have no idea how these were made. It could have been Substance Designer, could have been anything, but like there's a bunch of different noises.
It said in the description it was hand drawn.
Hand drawn? Damn. Oh, you know what? This might have been drawn with, you know the silk drawers? Here, hold on, let me like show you. Silk drawing. Like you can use, right, this. Yeah. And straight up, I think, yeah, so so you can use this. They have different ones. The Lua's noise is free though, so like you can just get that. Yeah, so like there are different, like again, being a VFX artist is about knowing tricks. If you happen to know, man, silk drawing causes this specific effect, maybe I can use this to my advantage. It's all about, it's not even necessarily about knowing enough math or knowing enough code. It is knowing all the tricks and how to put them together to make stuff. So that's how he did his noise. Let's go back to the Perlin now, because everyone can make this. You can just use GIMP. In GIMP, it should be cloud noise, if not literally called Perlin. Perlin noise, the reason it's called Perlin noise is because like a dude named Perlin was like, yo, if you use this algorithm, you can get randomness that is kind of cloudy. Congratulations. So it's not like regular noise would just be like a bunch of black, white, like, you know, snowstorm, like your TV. Actually, TVs don't do that anymore. But they, you know, y'all were young at one point. You probably know this. But Perlin makes kind of cloudy stuff. But don't worry about any of this. We're going to start coding. So how do we get lava to move? Well, let's look at our code here. What? You can ask the lava nicely, but as it turns out, you're not a wizard, so your words have no power. I know it sucks. We've tried, but this is how a texture is rendered. So in this thing called the surf function, for surface, not surfing, as much as we love surfing on the web and whatnot, we have the surf function which creates a surface. So what the function is doing is it is saying at every single pixel along this polygon, this is how you're going to render. Because what the renderer does is when you render a polygon, first it says, okay, what are the vertices of this polygon? Okay, cool. Let me shove you in a polygon renderer, make the polygon. Okay, what do I fill this polygon with, right? Because you like what happens is it creates just kind of like a blank texture. I think even you can kind of see this in the previs. Let's see, global, maybe not, I don't know. Maybe not, I don't know, like, okay, yeah, so like maybe by default, right? So it's wireframe, it says, okay, here, make these polygons, right there. Render the polygons, and then fill all of those triangles in with stuff. And what stuff, might you ask? Well, the stuff is determined by the UV. So let me show you what that looks like in code. In code, that is, fixed for C. I'm just creating a variable. This variable is a color, right? Fixed for is a four-dimensional float vector. The difference between you can have a float for or a fixed for. I don't know what the difference is. I think fixed for is kind of like const from JavaScript in that you can't change it once it's made. I assume, but I don't know. Just I use float for generally, and I don't care. Fixed for C is text2D. This is a function. What it takes in is main text, which is your reference to a texture, right? That is not like the texture itself is a reference, and it takes in.uv main text. What is UV main text? As we said, UVs. Why the letter U and V? Don't worry about it, but this just means basically an XY coordinate. So the UV is a coordinate that is mapped from the space of the model to the space of the texture. And what does that mean? Let me open up Blender. Let me just do a new one. I don't think I changed anything. Okay, so open up UV editing. Again, you'll notice UV editing. This model, though it is a 3D object, has this nice 2D representation of a cross. Right? You'll see, if I go to face mode, right? If I select this one, this face is over here, this face is over here. If I select all of them, right? Every single face has a space on this 2D texture. The reason for this is there's no way to transfer between 2D and 3D, right? Because the idea with models is that we are painting on them, right? And the only way we know where to paint, right? So, like, obviously in real life, we can just paint over a 3D object, but your computer's like, I don't know what that means. So we have to say, okay, when I touch this part of the model, this is where, or when I touch like this part of this texture, it should go to this part of the model. So Unity's default cube, you'll notice the UVs are actually overlapping, right? The top and the side are the same texture, right? So imagine that's basically like if I went in here. I think if I did that one. Nope, never mind. If I did that, I don't know. There's like I think sometimes there's a way of making it such that they overlap. But imagine it's kind of like I unwrapped, right? So I unwrapped every single side so that it was as big as the entire thing, right? So now the texture, the entire thing, will just go onto every single face, right? Now I have to like do this with every single one of them, but that's how that works, right? Does that make sense? Like, raise your hand if like that doesn't make sense, because I want to go over this is important. What's up?
So, like, you're changing. Can you just say it one more time?
Yeah. Okay. So by default, your computer doesn't know where the texture should go on your model, right? By default, it doesn't know how to do that. But what we can do is we can say, okay, I can map. I can use some kind of mapping. It's called a texture map, right? That's what they're called this. I can use some kind of texture map to say, okay, this pixel goes on this place on this model, right? So you'll see that there are vertices here, right? So like it's just like saying, hey, this vertex is here. Between this vertex and that vertex, a pixel might go like here, right? Depending on the resolution, it might go different places. There might be better explanations. Let me like Google UV map.
I get like when we had the like fold out of the cube, but the part where you're making it like really big.
Oh, so like modifying the UVs?
Yeah, I get
So the idea with that is, right, so like when we have the cross, right? Does this make sense?
Yeah.
How it's just kind of unfurled? Well, the cool thing with the UVs is they don't have to be this at all, right? I can just arbitrarily say, yeah, you're bigger. And that's kind of weird, right? But it's so basically it's non-continuous, right? So it's saying a pixel that is hereabouts, right? That is both on the side, I don't know like which side it is, on that side and also like the top. Let's say that that this one is the top, this is the side. That pixel now gets rendered on both. I know that can be confusing. It's like once hopefully doing the ring, if we get to it, I can explain, because like there are a lot of cool tricks you can do with UVs. You'll see it better. But for now, the default Unity texture, right? So like when I say overlap, right? Do you see how that's the same texture on all faces, right? Right? It's the same exact thing. The reason that's like that is that way is because they're all overlapping, right? Or not that. Nope, stop it. Right, so when I select both of these, they're overlapping, right? You can't even tell that there are two of them selected, right? They're overlapping so that in both places, that texture will show up the same.
So it's just like two of the same texture on top of each other.
So the UV is on top of each other, so the texture will go to two separate places the same. Does that make sense, right? Again, because the UVs are overlapping, the texture goes to those faces the exact same.
So it doesn't bother it doesn't bother drawing it once and then drawing it again.
Yeah, so it doesn't, right? Again, this is just a mapping. All it's saying is, at this position, this pixel should be drawn. I might as well just save this to show you like what's going on. So let me, by default, so this is the default. Let me save this on shader test 2, assets. Again, if you don't have Blender, you can get Blender. It's actually a really quick install, but it would be good. So let's just call this cube. So we'll call it cube, and I'll bring it in so we can actually see this in real time. Jesus Christ! What the? What? I don't even know. I mean, like it. All right, cool. Let me not have. I don't like know what material. Why would you be like this? That doesn't make any sense to me. Oh, hold on.
Oh wow, you can bring in
Yeah.
lights with your
Yeah, so like it actually imports the lights and stuff. Yeah, it's bad. Don't do it. Yes, actually, I made before Unity 2.8, I set up Blender 2.8. I set up Blender so that it wouldn't have the light or the camera by default. I don't know why that was happening. Suffice to say it did, so I don't really care. But I want to make this brighter because I want to make that. Yeah, I don't know, whatever. But yeah, so you'll notice, right? See how the texture is smudgier here, right? There's less resolution on it. Do you see? Right? On Unity's cube, the full thing's there. On this one, like a part of it's there, right? That is because our UV is only part of it, right? So we're getting only a small chunk of that texture. Let me see if I can't load an image. Test. No, where is it? Ring. Right? So rather than the full texture going into one small space, that one small space is just getting a chunk of it, right? Does that make sense? Raise your hand if this doesn't make sense, because this is the most important thing. What's up?
So there's an option either fill the entire bounding box upon which you build that.
So it's not just an option. It's not like you choose one or the other. You can make it however you want. So let's just say I modify not the face, but the vertex, right? So now, if I save this, I go into Unity. It makes a different kind of mapping. It's hard to tell because it's Perlin noise. Let's see if I can't make a better, if there's like a grid texture that would be helpful. Ooh, I might have that. Hold on. Yes, I should have something that I can use. Hold on. In my first person, assets, textures, test texture.png. Yes, perfect. So if I copy, bring that here. Now if I apply that to here, right? So the part which I distorted is now distorted. Everything else is straight, right? Right? See? Because I moved the pixel, because I moved the vertex, the pixels get distorted, right? Does that make sense? Cool. Okay. So you can do a lot of cool things with this. We'll be doing cool things later if we get to it, and I really want to get to it. But right, you'll notice now, hey, it's perfect again. So let's go back to our purlin. So we'll have that. Let's keep with this one. But this is to say that basically the only thing determining what that pixel should be on that mesh is this UV coordinate. So does anyone want to take a guess? How do we get it to move? With the UV, all right. What do we do to the UV? We move it, exactly. We offset, no, like that's correct. Again, it's actually fun. Shaders, again, are just a composition of very simple things. UV offset is like one of the most simple things, but it's so pervasive, it's so useful. All you got to do is you got to offset it. So let's just say that let's just add a float 2. So right now, this right there, UV main text, that is a float 2. The way that this works is you have a float 2, a float 3, and a float 4, right, for one-dimensional vector, two-dimensional, three-dimensional, 4, right?
What language?
This is C, I think? GSL, no, HLSL. Is it GLSL or HLSL? GL? Okay. Which I think is a variant of C or somewhere. Like, I don't know, it seems, the syntax is C-like. Not exactly, though, of course. But yeah, it's very convenient. Jesus Christ. This isn't flat because I need a drink. Okay. Ugh. You know, Sprite doesn't actually help your voice.
Yeah.
God, why? Regardless, let's offset this. So let me make sure this is in view because you can see what happens. Let's offset this by 1, 0 and see what happens. Nothing. If you want to know why, it's because UVs are in 0 to 1 space. So 0 is the 0 point of the UV. 1 is the furthest point of the UV. This is very convenient for your calculations because if you want to get halfway, it's always going to be 0.5. There's never you're never finagling between 1024 or whatever. Oh, what's my texture width? Let's set this by 0.5. I like this as opposed to C# because I don't have to add 0.5f. Why do I have to tell you it's a float? It doesn't matter. You know it's a float. Shut up. Doesn't matter. Hold on. If this, yep, there you go. See? You will notice, so my texture is not repeating. You can tell because there's this line there. So what I have done is I have offset for every single pixel. I've said, yo, you pixel, you're going to render right there? No, be 0.5 over that way. So that means the texture is moving across the x halfway. And because it's not repeating, you can actually see the edge of that texture. I can showcase this with different textures. Cube. I don't know which one of these. Yeah, so this one's repeating. You can't really tell, right? All of these are repeating, I think. So you can't tell so much that they're yeah, but this one you can. Obviously, the circle would be the center, but now it's not. Also, the nice thing is when you offset things and you move it in a direction, there is no. I actually don't know. There might be. There's probably a setting for this, but by default, it will repeat the texture. So if you go over, right, this circle, when you go over, it's not just black on that side and it just stays black. It actually wraps around. There's a way to turn that off, I think. I don't know if that's within the texture itself or within the shader. I think you can do it both ways. I don't remember. But if you don't want that effect, you can do that. But for the most part, you usually want it, especially for us because we're doing lava. So now we've moved it, but once. And that's not fun. We want to move it more. So how do we move it over time? So Unity has a nice built-in thing for all its shaders called time. I think it's literally just _time, like everything else. And it's time dot start with x. So time is actually a 4-dimensional vector. I know, I'm sorry. It's actually less complicated than you think. So it is, I think it's time divided by 2, and then time divided by 4, then time divided by 8. I don't know why that was the increments, but like, I don't know like what the increments are in. Like obviously there's no easy way of telling. It might just be 1 per second. I don't know. Regardless, let's see if this works. It should. Wow! Awesome, great, we're the best. Let's make it z, and see, this should be, I forget if it's divided or multiplied, but we'll find out. It is multiplied, so this is times 8, not divided by 8. But yeah, now your lava's moving real fast.
If it's moving without you playing it?
Yeah, what do you mean? Oh, is it not for you? Because if it's not,
I'm moving very slow.
oh, yeah, so also,
It moves once.
if yours isn't working, there's a drop down here for animated materials.
Oh yeah. I
Make
can
sure that's
see that.
checked.
Okay, it works now.
Okay, good.
Thank you.
Yeah, so that's the thing. Make sure that that's active. Also, if you never got your post-process to work, there's another thing for post-process here, which maybe you didn't notice. Actually, yeah, if you turn it off, wow, this is like dumb and red. Now it's bloom, right? You get it. Ooh, it makes sense. Regardless, yeah, that's how we do that. We have another thing. Let's say we want to have, let's make this back to, let's make it like x because lava moves slowly. Let's say we want our y not to move in one direction. We want it to move back and forth. So we could do, obviously, sine, which exists as a function of time, dot, let's do x, that's fine. And this should move up and down. Maybe it's like too fast still. Hold on, let me like make this .z, maybe that'll work better. Also, the nice thing about compiling shaders is that, oh, there you go. Yep, look at it. Still like a bit much, but like, that's lava, right? But yeah, so the nice thing about compiling shaders is it happens almost instantaneously, unlike Unity code, which like has to like take forever to compile. But yeah, so it's great. Let's make that time dot, I don't know, x, y, yeah, let's do like y. Should be like less slow. But also, let's say that we don't, so we want to actually control how far it jiggles or it moves, right? So what we want to do is we want to add another variable. So you'll notice here, man, we have 2 sets of variables, right? I told you one wasn't real. These others are real. So the way that this works is you always have to declare variables like twice. One up top saying, yo, this is a variable, make it real to the inspector. Then one down here, actually it's more important that you do down here first. Down here is what the variable actually is. So let's make a variable for amplitude, for like the amplitude that it goes up and down. So I'll just call this float amplitude. I don't actually know if you'd need the underscore or not. I never tested it. It just, everything has an underscore on it, and it seemed wrong not to. So actually, live tonight, we will figure that out. I'm going to get rid of the underscore, the mythical underscore. Let's make this 0.5 by default. I'll show you what it is to not have an inspector variable. Then let's multiply sine times amplitude. Hold on, I didn't add where, oh, equals, classic. That doesn't seem like, maybe you can't, you might also not be able to declare variables like that. But let's see, okay, so what we're going to do is, so that didn't work, but what we're going to do is let's just add, so because we have the variable down there, to actually serialize it for Unity, we create amplitude here, call it amplitude. This is the annoying part. You have to like type the variable 10 times, right? Like 2 times, one for the actual variable name, one for the inspector name, another time for the variable in the actual use, and then again whenever you use it. It gets really repetitive. Let's make this not a range but a float, and let's make its default value 0.5. And let's see if this works. Yep, it does. So now let's make the amplitude like 0.1. Right, now it's like very small. Let's make it like 10. Whee! Wait for it. There it is, yep. Yeah, so it works. But yeah, so like let's make it like 0.1 because that's like better, I guess. Obviously, this isn't how actual water moves or like liquid moves. You would do a lot more. In fact, like that video that you posted about like displacement maps, there's a lot more going on. In fact, normally with liquids, you want to have one going one way, another going the other way, and it kind of like adds together to make a nice effect. But yeah, you guys know how to modify UVs. Isn't that great? So now you guys know kind of like how to make liquid. In theory, if you just had a texture that looked like water, yeah, like you can do like Wind Waker's, opaque water, right? Because now you can just make that. Now, obviously, you can't make the waves move.
Yeah.
That is a vertex offset. I will not be teaching that today, but you can actually learn it. That is a very common thing people want to learn. So Unity shader vertex displacement is a very common thing people want to learn. And there's a thing, apparently, Kakashi Sensei will teach you shaders. Yeah, but there's a lot of things, right? So that sphere is the actual model, but they're offsetting the vertices with a shader, so you can do that. So if you want to actually do that, you can. I didn't want to get into it now. While important, I wanted to get more into UVs and other stuff. So let's see what we want to do. So it does work without an underscore, but I don't like it without an underscore, so I'm just going to change it. Let's go to that one. So what do we want to do next? I want to, let's see if we can't do some, oh, right. Let's do some cool math stuff. So ignore this texture. I'm going to comment this out. What I'm going to do is I'm going to color this myself. So what I'm going to do is I'll make a float and call it C. So we have C. And what we're going to do this time is we're going to take our in.uv main text. I'm going to use the X component. Now, what do you think is going to happen? This is probably going to be confusing. No one's going to know the answer. Okay. So what's going to happen is it's going to create a gradient. So what's going to happen is with X at 0, it's going to color all the pixels 0, right? And that's going to be black. When X is 1, at all the way at the other side, it's going to color it white as 1. Let me show you that, unless it breaks. Hold on. Oh, that's because hold on. Also get rid of this. So it says it's a fixed 4. We're not doing that. Let's just do C. The cool thing about GLSL is that it takes a lot of forms. It's very free form. So like straight up, if you just have a fixed 4, you can swizzle out just the R, G, and B, not the A. But so in theory, I could probably make this a float 4, though I don't know if that would work. It might not work. Just do it this way. But what it can't just take, so the albedo can just be a number. 0 to 1 does work because all colors exist between 0 and 1, just in different forms. But now, oh my God, A, come on now. This is just 1, and we'll delete that. Okay, so the alpha is 1 because we don't have an alpha. We're just doing the color. And now, ta-da! It's a gradient. Yeah, isn't that cool? So what we did, let's make this non-selected, right? So depending on the UV, at the 0 of the UV, it's just 0. At the 1, it's 1. It'll just create a straight-up gradient. This is neat for a lot of reasons. I'll be showing you. I actually use this for my ring. But the point is, you can do math. And you can use math to make textures do stuff. So this isn't a very technical thing, and there's a lot more technical stuff you can do, like depth buffers, crazy vector projections and stuff like that. Don't even worry yourself about it. worry about doing like neat things with moving textures, neat things with changing colors, and other stuff like that. Shaders don't need to be complex. They don't need to be like crazy, 1,000 line things that do any kind of stuff. They can be simple. So I guess we might as well start with the ring. Yeah, we have 40 minutes left, and then so then we can head out. So I'm going to show you how to make. I showed you guys the ring, right? I showed you guys what we're making. Making this. Maybe I didn't. So ultimately, we're making this. Did we?
Yeah.
Okay, I did. Yeah. So the idea was it was like the Breath of the Wild thing. And again, so I just got this idea. This thing that I looked up online, this wasn't a tutorial. It didn't actually show you how to do it. Like I swear to you, this doesn't require it doesn't require special knowledge. As long as you can see things and think through, okay, how do I translate what I'm seeing right now into a shader? That's all you got to do. Now, that's a hard thing to get to. This is ultimately what you're learning. Every time you learn an art, you're not learning how to hold the pencil. Like when you learn to draw, like you already know how to use the pencil. That's fine. You know how to make lines. When you learn how to draw, you learn how to translate a concept in your head into a gesture, into what lines do I need to form this object. With a shader, you have this ultimate goal here of what things do I need to do to make this effect? What do I have at my disposal? And so there's a lot of tricks involved. So I think literally every single thing that I showed you today, you could technically make this. Now, obviously, I wouldn't expect you to know how to do this right now, but straight up, all the math involved in making this happen, and tricks, is right here, or is at your fingertips. So the first thing that you have to do is let me just start over. So we start with the ring. So this is actually important. So the ring, let me open this up in Blender. Because I have to close this first. The ring is actually special. So normally, when you make, so the way I did this, I think you can make a circle, right? Let me just move this over. You can make a circle, you can E, you can S, and congratulations, you have cylinder. When you normally unwrap this, it'll unwrap like this. Now, again, if you don't know Blender or you don't know modeling, don't worry about this. The point is, the UVs are flat, right? They just map perfectly onto this, disk, right? Thing is, that's not what we want for this ring. You'll notice this line of stuff, right? So this effect just has a line of things moving outwards. There's actually a UV trick you can do to make this happen. So we made, our texture move in one direction, just this way. Now, we could do possibly some polar coordinate jazz that does a similar thing, or we can fake the curvature to be flat. Let me tell you what I mean. So again, normally, this UV, it's flat. The UV for this thing I'm actually using, is this. Now you're wondering, what does that mean? This means that all of these wedges are unfurled, right? Think about it. When I put a texture on this, it's going to be wrapped around the disk, right? If there was a line down the center of this, that line would be in the center of this object moving around. Do you see where I'm going here? Does that make sense? This is, again, why I think that shaders are a generalist thing. You need to understand, man, when I make a model and I make a UV for it, I can use that UV to my advantage. I don't need to just live with this. I don't need to live with the flat projection. I can modify the projection to be a rectangle, even though it's a disk. So let me show you what that means. So let me make a new folder. Create folder. Ring 2, just so we have another ring. Let's create a material. Let's call it ring 2. Let's apply it. Then on ring 2, on the albedo, let's put our Perlin noise. Right? You'll see the Perlin noise, that one square texture is being stretched all the way around. Right? Does this make sense? Raise your hand if this does not make sense to you. Because again, this is critical. Right? That one texture is going all the way around. Okay, cool. So, yeah, what's up?
Is that the ring with like the flat UV or the like?
That is with that is like, not the not flat one. Because I deleted that one and I didn't save it. Yeah, so this is the unfurled UV. The way that I did this is I have a thing called text tools. So by default, I added like a little, so like by default it would not have this. So this is a UV cut. This means that your UVs will split across this thing. So normally when I unwrap this, it'll still be a disk, but then I can go, hey, rectify. Now it's a rectangle. Yay! And then I just fit that rectangle to the square. What's up? I had to get this. So that is called Text Tools. Text Tool, it is free. Text Tools, Blender 2.8. And the problem is you have to it's not officially out. You have to go to a thread here. There's like a GitHub of it. I highly recommend, the reason I'm going through this is because I highly recommend actually getting it. Here it is, releases, yeah. So it's like here. Sav Martin did this, I guess. So yeah, it's right here. Get it, install it. You can use it to rectify. I don't know, Blender might have it in there, but I don't think it does. Regardless, I'll just make it what it was. But yeah, okay, cool. So let me now make a new shader. Shader, standard surface shader. Call it ring 2. I will then drag it on here. Nothing will change because the texture should be the same. Come on now, there you go. Let me unselect this because I want to actually show you stuff first. So, how did I do the ring? That's like the first thing, right? The first thing is how did I make that little actual ring that moved? So what I'm going to do is I'm going to actually open up my code because I actually forgot myself. But I'm pretty sure I remember the math for it. It is yes. Okay. So what we're going to do is the first thing is we're going to keep this float C. Yep, that is what I did. We're going to keep this float C. We're going to get rid of this. We're going to create another variable. Oh, no, this is not. This is the wrong shader. Oops, my B. Let's undo this. There it is. Ring 2. Where is it? There it is. Okay. The first thing we're going to do, let's just copy and paste this and then comment that out. I always like keeping the old code around because it's faster to copy and paste. The first thing we're going to do is make this float force C. Or not float force, just float C. Just going to fix this. Make this C. Make this C. Okay. So, yeah. Let's keep the UV main text. And then let's keep that. Okay. So, what we're going to do is to make a line. To make the line that, hold on, let's make sure who's messed. Okay, that's my Brian. Okay. Okay. To get the line. No, not what I wanted. Stop. Stop. No. Ring. Let's get rid of you. None. Where's the other ring here? Okay. So the default thing that this ring is just a position and this kind of gradient. So what this is actually just a linear gradient that starts, so that radiates outwards from a line, right? So there's a line going across this UV that's being bent, but from the sides of it outwards, right? From the line outwards, it's going like that, and so it starts at 1 and grades off to 0, right? Does that make sense?
It's 1 is dark and then it just gets lighter as.
There's no marker here. Hold on. If this will give me enough length. If we have a line, right? So that's 1, and it just kind of grades off into nothingness, right? Right? It's hard to show here, but it gets lighter.
Is it multiple lines or is it just a
It's just a gradient. So I mean, it's multiple lines in the sense that there are pixels. So like every pixel would be, less and less. But let me show you what that would look like. So first, let's make a variable. We'll call it ring pos. I'll just copy and paste it from here because I already have it. But ring pos is the ring position. Then what I did from there was the distance. So the absolute value, because the distance, we want just a positive distance between that dot x and ring pos. Yeah, I think that should actually do it. So if we just get this will create like a linear gradient. It should. Oh, right. Again, you're going to do this a lot. You'll create it here, but then you won't actually create it down here, and it's going to be like, it doesn't exist. It's because, again, this doesn't exist, as I told you. Let me see. Yep, okay, right? So there's a linear gradient from 0.17, or hold on, that's the wrong material, hold on. So linear gradient from 0, right? And as I move this ring position, that gradient moves. Does this make sense to people?
What are you moving with ring position?
So I'm moving the distance, so I'm moving basically, ring position is like the UV coordinate that it measures against, right? Remember the code. So the code here, the absolute value of main text minus ring pos. So what this is doing is, right, so for the absolute value function in math is, right, it's this from 0, right? So ring pos is deciding where along the x-axis this function is, right? So it's either here or here, right? And then the gradient is, okay, when it's there, it's 0. When it's not there, it's somewhere between that and like 1, right? And it just keeps getting brighter. Does that make sense to people? Cool. The next thing that I did was I'm not sure where I put the power in it. I think I put the power. Regardless, I wanted to make the sharpness of the ring. Yeah, there it is. Okay. Yep, okay. So the next thing I did was I subtract 1 from this, or I subtracted it from 1. Okay, so if I have this, if you subtract this from 1, what do you think you'll get? Right? Or 1 minus the absolute value of x. It'll be flipped, right? So before we had black becoming white. Now we will have, hold on. I did not save it, hold on. We'll have white becoming black. Right? Does that make sense? Huh? Yes. Because we're subtracting that from 1, you're getting white becoming black. The next thing that I did was this. I used the POW function. What's up?
Why can't you just do negative absolute?
Because that would be negative x and negative 1 isn't a color.
Okay.
It actually might exist in that because we're linear, it actually would work, but I don't know what that would be. Next thing I do is the POW function. POW is raising a thing to a power. So I have this thing called sharpness. I'm not going to do it here. I'll just make it 20. This is making this sharper, right? So what I'm doing is, since I'm raising it to a power, this absolute value kind of does this jazz, right? It just becomes sharper. So rather than becoming, black slowly, it becomes black really freaking quick, right? So now we're already getting that kind of ring effect, right? Cool. So, crap. Now what we want to do is actually want to make it colorful. So, remember when, it was a long time ago when I said multiplying color and how that made sense? Like I said, multiplying, so this is a number between 0 and 1. If we have a color and we multiply it between 0 and 1, what we're doing is we're just, hold on, let me actually just do it, times color. Let's make this red, right? Where it's white, it is red. Where it is gray, it is somewhere between, some kind of grayish red. Where it is black, right? Because black, red times 0 is 0. And you can do a lot of math with that. I know a lot of people have stopped coding, so I feel like I've lost you. I don't.
Mostly because we don't have.
Oh, God, I wish that it was working. It could have been so helpful. Man, why does, I make teaching tools to help people and then they don't work. But yeah, so you get this. Now I'm teaching you this. This is a very specific thing. I want you guys to know that this isn't how every shader is made, of course. The hope is that you learn the idea that you're just doing math to stuff, and then that math is creating a thing. I will point you guys to a shader tutorial guide that I really like, and I will point you guys to many tutorials, many resources at the very end. I want you guys to avail yourself of those. That is how you learn. I did not learn by learning everything about shaders and then just making them. I learned by copying and pasting and then prodding them until they worked. So yeah, cool. Now we have this. Similar, right? Now, what do you think I'm doing to make it invisible? Alpha, exactly. Now, you'll notice, right? So obviously the alpha should just be, hold on. Yeah, so the alpha is C right now. That's not doing anything, right? So in theory, the alpha should just be, when it's 0, it should be, you shouldn't see it. That is because by default, the surface shader doesn't have the right stuff in it to make it actually invisible. This is the weird technical part of shaders that is annoying. There's a lot of these tags that you need. One of them is just Q transparent, render type transparent. This just needs to be at the top. The Q, I don't necessarily think it needs to be because Q is just when it gets rendered in the queue. So there's a render queue. Stuff that gets rendered earlier is the first, right? So that would be the skybox, right? Because that's the very back, right? Stuff that gets rendered last is like the UI that is over everything, right? Transparent is right above all, so it's kind of in the midst, but at the but above normal geometry. You'll notice that transparent doesn't get affected by certain post-processing effects. Like ambient occlusion, it doesn't get affected by it because it is too high in the render queue. There's a lot more about render queue, which you can learn. It's actually kind of cool things. You can actually do transparent -1. So transparent, there are 1,000 slots in transparent. So you can actually be okay, so this transparent thing needs to be behind this other transparent shader that I have. Or this transparent shader that I made needs to be behind every transparent thing that I did. So I'll make it -100 to be in the midst of transparent, but behind it, right? Don't worry about that too much, but that is a thing that you can do. There is a way to sort shaders like that. You also need this blend circ alpha 1 minus circ alpha. What does that mean? This is how it blends with materials. So it takes, basically this is saying, okay, the source alpha, yours, and then the one, or either, actually no, not yours, and then this one is yours. So it'll take, okay, how visible am I? So let's just say I'm 0.5. It will take 0.5 of the color behind me and then 0.5 of me and then add them together. Does that make sense? I think there are different ways of actually adding those things together. Then the final thing, which is also annoying, is alpha fade. You think that the other ones would get it done, but you need this. This is the other annoying part about shaders. You don't not only do you need to know math, all the UV stuff, all this other crap, you need to know all these technicalities, all this other stuff. I guarantee you what you're going to do is you're going to forget about it like I did, and you're just going to Google it, and you're going to remember, or you're just going to copy and paste. It's what you got to do. I'm sorry, that's just how that's just how it works. Or what you're going to do is you're going to write a bunch of shaders, and you're going to be oh shit, how did I make that other shader? You're going to look at that shader, and you're all right, cool, done, fantastic. Now, ta-da! Perfect, right? Great. Now, in fact, so right now it's not HDR, but let's do it. HDR. Another thing I'm going to do is I'm not going to multiply the color by C, right? Because now that we have the alpha, I don't need to change the color at all, right? I don't need to make it darker. So now it's red. Let's make that bright. Cha-ching. Now I can change the sharpness. Let's make the sharpness, I think it was like 50 on the other one. Now the sharpness is 50. Now it's a good ring. Cool thing is, you can actually use this right now. I mean, like, you know, what, like, let's just say you want to have an indicator, right? You can just have it like kind of like float up and down. You can actually use it right now, right? Actually, man, okay, so I'm actually just going to upload the shader to a zip file, and you can actually mess around with it to see what I'm doing. So if we don't get to it, I want to actually show you how to modify this with code, because this is actually very important to VFX. So the cool thing is, see these modifiable values? If you want this to animate, like let's just say we want this to be an indicator. This is like an RTS. There's like a goal here. You want to do that, right? So you can actually modify these values in code. Let me show you. So let's add a component. Let's call it ring. New script. You can create scripts, and if it'll do it. Did it add it? I can't see it. Are you going to be like this? I don't know why it's doing that. Like, I don't even have any static elements. So, all right, cool, awesome. Great. Okay. Now, once this loads, what we can do is we can reference the renderer. So what I'll do is I'll call it, actually not the renderer, so we'll make it a material. So everything has a material. It's called M. Or not everything, right? It has, because we have a material renderer component which has a material, we can get it. So what we're going to do is at start, we're going to do M equals get component renderer. Now there is a like mesh renderer and a 2D renderer, but we don't actually have to specify here because render is just a superclass. So we can just say, all right, whatever renderer you have, get that dot material, and now we have this material. Now, one technicality is Unity by default does not garbage collect. So what happens is when you modify variables of this material, it will create a material instance. That material instance will not get garbage collected. So if you do not destroy it yourself, it will stay in your game forever, and you will have memory leak issues. There are two ways of fixing this. One, shared material. Shared material is the global material. So let's just say you have two rings. I can actually show this in effect more easily. But if you have two rings, the shared material, if you modify that, both of these rings' materials will get changed by this one change on this one script. So let's just say if you want things to happen in unison, like given the texture, cool, or given the material, cool, just use that. Because what that is doing is it doesn't need to garbage collect because that one material already exists. What's up? Only things that have that material that this thing is applied to. So this thing, because it has the lava material, I think this one has the lava material, this one will not get affected. Only the shared material between these. So only things that share literally this material. And you'll see, when you do things in script, this like object in your project is going to get modified if you use the shared material. If you don't want to do that though, let's just say you want to have them independent, what you have to do is on destroy material or M, or actually what, destroy M. Okay, that's all you got to do, I think, as far as I am aware. This has worked with other games for me without memory leak, so it's probably okay. If not, you can like say, hey, John, you're dumb and I hate you. And then I'll say, all right, well, I'm sorry. That's all I got. But yeah, so just make sure you do this. There are memory leaks. I say this to you because if you didn't know this and you try to modify stuff in script, bad stuff will happen. I know it's like a weird technical thing, but we need to do this. But what we're going to do now is m.set float. So m.set float lets you access variables in here. So we have ring pos, m.set float ring pos, and what we're going to do is we're going to make this mathf.sign time.time since level load. Yes, that should work, right? So what do you expect this to do? Yes, the ring will go big and small, I hope, if I'm not wrong. This should be fine. Let me click on this. So which one has the script on it? I think it was this one. Let's make sure. Yes. Okay. So hopefully, if I'm not wrong, so wait, why? Hold on, this one shouldn't be doing that. Oh, that's because it.
Changing the material, right?
Yeah, there shouldn't be. I don't know why that has an inst. Oh, because they both have scripts on them. So actually, right, because I duplicated. So they're both actually doing it. They're actually two separate instances. I will. Here, hold on. Let me delete the script. So just to show you that it is in fact an instance. So that's because it was going -1, right? So -1, we didn't handle that case, right? So if we make this, right, so instance, right? So it's only affecting the one. So let me actually do, what is it, 0.5f times that plus 0.5f. Yes. So that will squish it between 0 and 1. And now, voila. In fact, I mean, you did this with history hex when you modified the color, right? Actually, no, maybe not. Maybe you didn't do a similar thing like this. I know you modified the color of your hexes. I don't know how you did that. Yeah, exactly. So material by default has a color thing. Now, mind you, the range I set on my on this thing was actually like 0.01 to 0.99 because at the edges you'll see like it kind of gets cut off, and right, because the texture wraps, right, you'll see the little ring kind of reappear, I think. Yeah, like you get that little bit of black coming back. That's again why in the material I set the range from 0 to like 0.99. Regardless, you can modify stuff in script. I just want to let you guys know that this is possible. That's how VFX are made. You need to have everything working in concert. And like there are small things. That's the cool part. It's small. You don't have to like worry about doing a lot. But you do have to do some stuff. So now we made this like nice little selector ring. I don't know, that could be useful for people. Actually for you, maybe like if you want to do like a spell, I don't know, right? Yeah. Let's see. I could finish out the ring. Do you guys want me to finish out the ring shader? With the like dissolve effect? Like, yeah, might as well. Okay. So let me finish out the effect. I'll be kind of fast again, like I like to get the rest of it, but hopefully I'll explain, if not like the code line by line, what is happening. So with the rest of the shader, what I have going on is kind of a lot. But let me get both of this in here. Do I need to clip? I think I do need to clip because I don't do alpha. No, I do alpha. Why do I do alpha? I shouldn't do alpha. No, I guess it's fine. Okay, so right here we have R. So R is the ring. Let me actually change this to R. Let's make this R. So we have R. What I do with R is, I also saturate it. So what does it mean to saturate? Let me show you. So saturate, I don't know why they call it this. Saturate is clamp. Saturate is clamp between 0 and 1. I think there's also a clamp function which you can specify what numbers, but saturate by default clamps it between 0 and 1. Why it's called that again, I don't know. The reason I do this is because if it's less than 0 or greater than 1, I don't want that like messing with anything. I just like it to be at 0 or at 1. Again, it's nice. So again, with color, right, if it's beyond 1, it gets glowy. If you don't want that to happen, but maybe you know it's going to exceed sometimes, just do that. Again, tool at your fingertips. You might not need it for, like, again, it's a specific instance. Now I have C. C here is my texture. So the way that I got, you'll notice in my ring, so that's a clean ring. Here I have it kind of, hold on. There it is. Okay. Here I have the ring kind of broken up by this noise, right? It gives it that distinctly, right? Like it gives it that effect that the Breath of the Wild thing has. It gives it kind of like a rough look. So what I can do is that because I have this ring, right, that's kind of going all the way around, I can actually sample the texture at all those positions and see, is it white or is it black? And then multiply the whiteness or blackness to the ring. So now, instead of it being a perfectly round ring, at different points, it's going to get different colors, right? Does that make sense? You seeing that? Like, tell me if it doesn't, please. Okay, cool. Might be a good idea to get rid of the color. I wish I like broke this down better. But if we take this, so let me like start over here. So if we get this text 2D, let's not do that. So now we have text 2D. We have in.uv main text, right? So this is just the same thing as we have up here, right? I am sampling the texture at these points. What I'm doing, though, is I'm offsetting it by a ring pos. The reason I'm doing that is without this, it would sample differently at every position. I'll take it off and I'll show you what it does. So if I do this, let's do alpha that times C. And then let's see what happens. And that is because this is white by default, so it doesn't have anything in here. Now let's get this. Now you'll notice it kind of changed, right? Like it's like different at different areas. If I change the ring position, you can kind of see it. It's kind of weak. Hold on. Here's a better texture for it because this has a lot more black in it, right? So you can see now I'm multiplying a texture at certain points, right? So now I'm not moving it, so that's very cool, right? You like that? Now that's very magical.
Doctor Strange.
Yeah, so in theory, you can kind of do this. Again, also, if you wanted to, you can now also move the texture over time, so it's actually moving around the ring. Actually, let me show you that. So if we wanted to, we can move, so rather than do this, we can do time dot, let's do x. There you go, Ring of Fire. So now, but you'll notice when I move the ring, right, it changes. That is because it is sampling different parts of that texture, right? That texture is being, let me like select the ring fully, right? So remember, again, the ring is a disk, right? And that disk has that texture all the way around it. When I move the ring, it is getting different parts of that texture. Does that make sense? Yeah, so like it's kind of like, why do I keep moving here? It's kind of like if I had, I don't want to erase this even though I should, yeah, fuck it. Yeah, fuck your math. Right, so imagine this was a square or rectangle, right? I have like a material all about here. My ring, my like line, or like my ring is actually a line, right? Because I'm bending it. My ring is getting different portions of this, right? So at here it's getting this part of it. At here it would get this part, right? Which is different, right? Does that make sense? So when you pan it, it's going to get a different part of it.
Does it always go horizontally or does sometimes it go vertically?
What do you mean?
Like,
Like the line?
yeah.
If you wanted to make the line go vertically, you would use the Y, right? Where we use the X position, right? So the way that we're making the line is, you know, stuff that is further away X-wise gets blacker, or yeah, it gets blacker, and stuff that is closer gets whiter. If we wanted to make it vertical, we can make that stuff that is closer Y, right? Would get that way. But because of the way that our ring is structured, the way that like if we made it about the Y, it would look like basically it would look like a spoke. Just a single spoke has a gradient on it because that is the extreme of the Y, right? There's just like one part of it. So yeah, we don't want to do that. But so as I said, it samples different portions. I don't want it to do that. So what I did is I subtracted ring pos, right? So now I'm offsetting the texture by the ring position. So now when I move the line, the texture moves with it, so you're always getting the same part. There's a reason I did that. It doesn't, like, again, if you don't want to do that, you don't have to do that. Again, it's shaders, it's up to you. The reason I did that was because I wanted to have it be consistent. Right, so now it looks different, right? It's not changing based on the position, right? So it depends on what you want to do. If you made it fire, you would want it to change, right? Because then it would look cooler because it's moving more. Here, I wanted it like that because the fadeaway effect looks better when you have a consistent, like if you look at this shader, right? the way that it fades away, it's not like changing the composition of the line. The line is just kind of dissolving, right? You get it's a very consistent dissolve, right? It's just kind of like slowly dissolving at different points of it. So I wanted it to be consistent. So the other thing that I did is, as the ring gets further and further from the center, I make it blacker, right? So as it gets further away, it gets darker. In this case, darker means less alpha, right? Less opaque. So what I'm doing here is I'm multiplying it by, let me just start with, so if I just want it to be like this, 1 minus in.uv main text, this would be a linear fall off, right? Do you understand this, right? Does this make sense? As the x value gets bigger, it becomes closer to 0, and when you multiply it by 0, it gets blacker. So let me show you this. Did I save it? I might not have. I did not. So if this loads, as this goes along, it gets less opaque. I think you can kind of see that, right? It's hard to tell. That is because it's linear. That's why I added the power function, right? So now, much like our gradient that we did the power function on right here to make that one go faster, we're going to do it with this one. We're going to do by 5, right? So now it should fall off a lot faster, right? So we start here, not that one. Yes, that one. Yep. So now it disappears a lot faster, right? Does that make sense? So already that's pretty much that's almost it, right? I mean, it's practically the effect, but it was blue. It's not. Hold on. There we go. Yep. Yeah. So that's kind of the effect. Obviously, it's a different again, the texture matters a lot because it's a different texture. You get a different effect with it. With this one, you get a very much cleaner line. With the other one, you don't. Right, that one changes it very little. That one changes it a lot. These change it by different things. Again, it might be unintuitive seeing it now. How might this texture change it? Eventually, you'll get that sense just by doing it, right? Because there's a lot of black in this, more of this is going to be invisible. And obviously, because we're warping it around stuff, it's going to look really weird. But the last thing that I did, was there even a last thing? Oh, yeah, I added this clip thing. So clip is neat. Let me show you. So also multiplying R by C. The reason for this is I wanted so rather than doing this down here, because in all cases I want to use R times C, R being the kind of the line gradient. So R is the line, right? That is just the gradient that we have for the line. C is the kind of erosion that we have, the texture, right? So in all cases, I just want to erode the line by that texture, so I just multiply it here. I also have clip. What clip does is it says anything less than 0, I will just get rid of. I'm just not going to render that pixel. So it's straight up see-through. So it's a nice, cheap way of having just not rendering anything. So even if you don't have that whole alpha nonsense that we had, you can just throw away the pixel. So in fact, if we just made alpha 1, we're still going to get it thrown away, right? So we're going to get less. So in this case, it's not. But you see how before it was kind of swimmy, where it had parts that were less bright. That's because we have the alpha, right? Because it was kind of 0.5 or something, right? You'll see here, right? There's a bit more going on with clip. Because of clip, we also get rid of that to show you. Yeah, it's more wispy, right? There's more wisps going on. That's because when I add clip, well, that just disappears, so it's a lot harsher. The reason I wanted it harsher was because this is kind of harsh, right? You kind of tell. You can also modify the clip value. So again, if it's a less than 0, so if I make this 0.01, right, it's going to be a lot nicer, right? A bit more wispy. Make this 0.05. Right, so like, you know, no, what, how? All right.
Oh my god.
There you go.
Shoot.
All right, well, we just got there. So if y'all can see that, I mean, people at home can probably see this. So this should, I don't know why, there it is. Yeah, right? Right? So now you kind of get that effect. Obviously, it's kind of slow, but, right? There you go. This is straight up just not working anymore. There it is. I mean, that's a good place to end as any. So, yeah, that's shaders. I know you have questions. Don't clap for me. I don't deserve it. No, no, no. But yeah. So this is just to say that there are a lot of ways you can do VFX. This is just one of them. Again, there's code. I didn't show you animation curves. Animation curves are another way of doing things. Actually, we should do a tutorial on those because you can use those literally everywhere, including VFX. But yeah, so I'll hopefully post the shader so you can have access to it because I know like some people might want this to mess with it or like, use it for their games. Again, if you ever have questions, actually, damn, because the thing wasn't there. I will also post links to the websites, which I think will be helpful to you guys. I know there are abundance of tutorials. Not all of them help in the ways that you want. I will try to find you ones that you can do. Also, I'll just end the stream. Thanks for tuning in.